Let's take a look at example number 3 and example number 4 dealing with rigid transformations. And for example number 3, we want to graph the function h of x is equal to x plus 3 cubed. The first thing you always want to ask yourself is, what does the mother function look like? And if you take a look here, because we're dealing with cubing something, we're going to be dealing with the cubic function, which hopefully you remember has this appearance. The cubic function has that general appearance. So when we go to sketch it, what we're going to do is we're going to draw a picture of the Cartesian plane, and we're going to use transformations. Now, transformations are telling us that we are adding a number to the inside of the function. And anytime we add a number to the inside of the function, that means we're going to pick up the function, move it to the left 3 units. So if the normal x cubed function looks like this, x plus 3 quantity cubed, and I'll write the answer over here in a red pen, is going to be that function shifted to the left 3 units. So the answer looks something like this. Again, our answer is this one over here in purple. Now let's take a look at example number 4. Let's talk about how we can graph j of x is equal to 4 plus the square root of x minus 2. Again, we need to first identify our mother function, and our mother function is the square root function, which, if you remember, has this general appearance of that arm kind of stretching out. So let's talk about what the graph of this function will look like. Now, we have this arm stretching out, and because we are subtracting 2 from the inside of the function, that means we're going to move the function to the right 2 units. And now we're adding a number to the outside of the function. That's what that 4 plus means. And remember, anytime we add a number to the outside of the function, that means we're going to pick it up and move it that many units. So we're going to go up 4 units. Okay, so the original square root function has this general appearance over here. But now I have to take that, move it up 2 units. So we're going to pick it up and move it up 2 units, and then move it to the right 4 units. And we have to maintain that same shape. It's a rigid transformation. And we'll put our answer over here in green. So going up 2, 1, 2, going to the right 4. We're going to start over here. We're starting at the ordered pair 4, 2, and we're going to sketch that function. The answer is this result over here in green.